Hey everybody, just disappearing, reappearing. That's how it goes. I can't even talk today. But anyways, we got a good question here from the internets about determining if box plots are independent or dependent. So let's grab the notepad. I reset the computer last night, so I got to load everything up right here. We'll see who's in the chat. But this is going to be the first question of the day here at 1 4 to 3 Stat 201 project independent. That's dependent box plots. Let's take a look at it. Here we go. Okay, so when it comes to box plots show us the 5-number summary. So we've got a lot of information to talk about right here. So you are looking at side-by-side box plots. And there's a few ways this could go. The absolute most independent they could be is if they look 100% identical and they're in the same spot. This is the most independent they could be. So this is absolute independence, because let's say we're looking at scores on the test. So the box plots have a y-axis that is quantitative. So this would be like test score, which is a quantitative. How much did you score on the test? And we have here people who took version A of the test and people who took version B of the test. So with this, you would say your test grade or the grades on the test were independent of the version. As The Rock would say, it doesn't matter. Whether you took version A or version B, it's going to be a grade that is of similar distribution, we should say. So there's the distribution of grades of B and the distribution of grades A, and it's not going to really matter which one you take. They're both similar in distribution. Now, you might see slight differences. So we could see a little bit higher median, maybe a smaller range. So we decrease this a little bit right here. At this point, and the IQR also decreased there. So there's a higher median. And I'd probably quote these values. So we might say that B has a higher median at this point. Maybe the median for B was something like 90, which would be awesome. And the median for A was 88. We go down here to the bottom of the distribution and we see something like 80 right here. And this is 78, where this is 100 and this is 99. Those are the max right there. There's no outliers in these either. So you would say the range of the distributions of grade B is 19, where the range of distribution of grades A is 22. Comparing the medians, we see a difference in medians of 2. And overall, I might say that these are still kind of independent. These are small differences which seem likely by random chance. So at this point, this is not completely independent, but seems going on the side of independent. But now you might say, well, what does dependent look like? And it doesn't mean 100% dependent. It doesn't mean we know what grade someone will make. But if we were to kind of rework this example a little bit more and drastically change what we see right here, we might see stronger evidence of dependency. So if you were to see something where you had a box plot all the way up here, and let's kind of decrease the range of it a little bit. And so there's a very high box plot. We can actually just redraw it. It's probably gonna be quicker. So we draw a box plot up here like this, and then we draw the median. We put a really high outlier right there. Go like that. And then we have the other distribution of grades right here. We're gonna redraw it too. So now we see a completely different kind of distribution between grades A and B, where A might have a minimum. This is all just hypothetical, a minimum value of, let's say, an 85 and a maximum value of a 102. And right here, the Q1 would maybe be like a 90. And this is, let's say, a 95. And there we go. So then this value up here, the max right here should be something like a 93 if it's in between those. And the min down here is going to be something like a 70, and we'll call that a 74, and we'll call this a 80 right here, and we'll call that a 76. These are all hypothetical values, and I didn't put in the median right there. So it's very important to know that you're seeing the min, the Q1, the median, the Q3, and the max. Let's write those next to it. This is the min. This is the Q1, the 25th percentile of the data. The median, which is also known as Q2. And this is the Q3, and this is the max right here. Remember, you can always take, let's see who's in chat. Hey, Julia, good to see you here. You can always take the differences between these to get the range of the data to compare those. And you can take the difference between these to get the IQR. So would this mean that the more differences the box plots have, the more dependent they are? Exactly. Julia, perfect answer right there. So this is like a very high level of dependency. Julia, if I offer you test A or test B, which one would you take? If you knew that, if you saw this right here, hey, Blake, good to see you. We're talking about box plots and how they can show dependence versus independence, or evidence of a dependency, we should say. That's probably a good way to say it. I would definitely take test B, right? You'd be like, do you want to take test A or test B? You'd be like, looking at the distribution of grades, I'm going to go with test B because I think my grade might depend on the test I take. So in this instance right here, we see strong evidence of a dependence. And you don't have to have it this drastic. I'm kind of going towards the extreme right here where there's very strong evidence. You might say there is some evidence or weak evidence, or I don't really see much evidence. You might say they look kind of independent. They look kind of dependent. You don't need to go full like, because I mean, could someone do better on test A than test B? Most definitely. We see over here, this person got a 93, this person got an 85. But it seems like there's, you're welcome, Blake. Yeah, great job. And this is the key concepts right here to understand that we're just comparing distributions. And the idea of dependency would be, does knowing the test somebody took give you information about their possible grade? Not saying you know their grade, but you're like, you took test B, oh man, you're lucky. And they're like, well, I made an 85. And you're like, hey, test A, the grades were much lower on test A. Like the median grade was a 76 compared to the test B had a 92 median grade. So you want to think about, do these differences matter? Do you care about the difference between medians? If you think about a 16-point difference in median grades right there, is the difference in range very different? The range has they might be similar in range. That's a range of 23, where the other one's a range of 27. So the test, but it might just be due to outlier right there. It might say that about B. Like they're kind of similar in range, maybe due to the outlier. B has a bigger range. My drawing kind of makes them look very similar. But you might say things like that. Does that make sense, Julia? Like to be like, the biggest differences here look to be in the differences between medians, where it shows some dependency that people on test B had a higher median with a 92 than test A that has 76 median. We also see the minimum values are vastly different, with a minimum of 85 for B and a minimum of 70 for A. Also, the maximum values due to an outlier in B is 102 versus A is 93. The values of ranges are very similar, with an IQR for A. So A has an IQR of 6, and B has an IQR of 5. And make sure you realize I'm getting the IQR by subtracting these numbers right here. These are the IQR numbers, or the Q3 and Q1. Their difference is the IQR. 80 minus 74 is 6. And then the range. So in terms of spread, they're kind of similar. In terms of spread, they're not that different. In terms of kind of percentiles, and which the 50th percentile is the median, the percentiles are pretty different though. So I might say the biggest differences we see, which show some dependency, look to be the differences in medians and also quartiles, like the 25th and 75th. So really good stuff right there. I hope that helps out the person on Discord asking about it. So that is how to talk about box plots. And we could look at, I think I've got the data open. Yeah, this is the data set you don't have. All the sniffles. Let's go here to Greek life. And let's go to number of pets you own. Let's do that. Now, this might be a weird one, or I'm doing it this way. I'll do it the way you do it. So go to Graph and then Graph Builder, Graph and then Graph Builder. Under Graph Builder, put the X variable down here on the X axis, which will be a 2-level categorical X. So you see 2 levels, yes and no, or just another 2 levels. 2 levels just means there's 2 answers to the questions. And we're going to do number of pets someone owns and put that on the Y. Make sure it's blue for quantitative. Now, a lot of people have 0 pets, so that's going to create a kind of large bulk of data down here at the bottom. We're going to click the box plots button right here, and then after we do this, we are going to click the 5-number summary button, which is down here at the bottom of the screen, which you can't see. Right there, the 5-number summary. We're going to click done. Make sure to click done. And then you're going to want to kind of stretch it out a little bit and make it look all nice and pretty right here. So I would say we got a good looking one right here. Now, what do you think about this? I think this is a pretty decent one to talk about. And what would you say about the distribution of pets that people own based on Greek life? What would you say from our discussions? It looks mostly independent or very dependent, or where are you leaning towards, independent or dependent? So look at the values, and I think this one's a good one that if you followed along right there, you can kind of be like, yeah, it looks mostly this. What do you think? Don't worry if you get it wrong. Just take a shot at it. We got to throw some points here. First person who answers gets the chat points. So what do you think from our discussions? What do you think? 10,000 points on the line right here. What do you think? Mewbots awaken the chat. Mostly independent or mostly, what do you think? You lean toward independent or dependent? Which one do you lean towards? And then I'll show you how I would look at it. Yay, Julia, we're going to throw you 20,000 points. That is the exact answer. So, and I would still stay with that. Like, even though there's some outlier, there's kind of two very extreme outliers who own tons and tons of pets on the non-Greek life. The big thing to notice, and Julia, just amazing work right there. That's the exact answers I would go for right there. With your understanding, there's just kind of some small differences due to some outliers. So if you take a look at what we have right here, and this was just a random one we chose, look at the stuff that lines up. Like, you want to see how similar these values are. That's the exact same. That's the exact same. That's the exact same. That's the exact same. And they don't have to be the exact same to say they're independent, but the closer they are and the more you're like, I don't really care about that difference, the more independent they are. So you have to use some judgment. This was a good one to be like, this one should be like pretty, if you saw this, I'd be like, that's pretty independent. Like, you would say, you know, mostly students don't really own pets. If they do own pets, they own one. And then students who own a lot of pets sometimes own two. So, you know, the upper 25% of students own two pets, and it's the same for Greek or not Greek. The 50th percentile students, which is the 50% own this or more or less, because it's the 50th percentile, own one pet, where the 25th percentile students, which 25% of students own zero pets or less. Then there are some extreme points, and I wouldn't say this shows some dependency. It's just some outliers over here. And if you look, even the other outliers look the same, so we should circle that in green to show it's similar. So the majority of this is very, very independent. It looks like it's just from one big data set. It's like, well, there's just a few extra outliers over there. In the one sample Z, why would testing probabilities be important? Also, can you pick a hypothesizer? So you'll be testing for the two-sided hypothesis test. All right, is this all one sample Z right here? We could do one sample Z again. Is this all one sample Z, or are you asking for the two-sided hypothesis? Or are you asking about the two sample T? So can you clarify the last part of that? And I'll do this all right here. Are you asking about the two sample T? When you say two-sided hypothesis, is this all one sample Z? Let me bring up the project, which is due tonight for extra credit. Highly suggest turning it in. Get that 108. Is this all one sample Z? All one sample Z. Okay, let's take a look. And there was one thing I didn't do in the one sample Z, so I actually kind of want to do it again here. I didn't do, and thank you to our SI leader who asked if they still need to do this. And I was like, yes. And then I looked and I was like, oh, I didn't do that. Because sometimes I am doing it by memory and I need to look at the project. It is in the instructions. So one sample Z. Okay. So right here, Julie asks, in the one sample Z, why would testing probabilities be important? Because probabilities are proportions. So the proportion of students who eat at Taco Bell is the probability. Good to see you, Evan. The proportion of people who eat at Taco Bell is the probability of people eating at Taco Bell in a large population. So to test one sample Z, we need a what kind of variable? To do the one sample Z, you need a what kind of variable? To do a one sample Z, you need a what kind of variable? How can I start this question? So I have to start this question by picking a what kind of variable. Yeah, definitely. Use the videos, make sure to follow through. Think about explaining things properly. I would say it's a couple hours worth of work, but follow the videos. Categorical, one sample Z is categorical. So we're going to go over here and we're going to look at our categorical variables. I think you can actually go right here and select certain columns. I used to know how to do it. Column selection. No, maybe I don't know how to do that anymore. Look for the red ones. So the red variables are categorical. So let's go to a 2 level, like, are you in the honors program? So with this right here, this is, are you in the honors program? If you actually click it right here, you can actually select it on the Analyze Distribution tab. Analyze Distribution tab. So under Analyze Distribution, you've now selected the variable and you can click Y columns. With Y columns clicked, you can now click OK and it'll show you the variable. Now, before taking a screenshot, we're going to make this look nice and pretty right here. So go ahead and click the top red arrow and click Stack. Click the top red arrow and click Stack. Boop. Now click the second red arrow and go to histogram options, even though it's a bar chart, and then go to count axis. Histogram options, count axis. Now, if you want to make it look really pretty, you can stretch it out a little bit here. Whee! And then you can also go to the second red arrow again, histogram options, and go to histogram color and pick a nice purple if you want. Oh, it's nice purple. So here are, you don't do the last little bits right there, but that makes it look extra pretty right here. You want to take a screenshot, make sure your screenshots look great. When you take a screenshot, you can always take a little extra if you want by accident, but then crop your screenshots to make them look nice and pretty. Use snipping tool or Command Shift 4. Snipping tool is on PCs. It's this little snipping tool thing down there that you see. Command Shift 4. I see it right there, Evan. Good to see you, Evan. And if you take too much on a screenshot, which you don't want to take too much, it's better to take too much than too little because you can always click the image in Word, go to picture format, and then go to crop. Click the image, picture format, and then crop, and then bring in those little edges right there. You want to click that little black bar right there and bring it in and make it look nice and pretty. Now, last but not least, we probably don't want our image this big. So go right here to your image, make it look a decent size. And you can even do things, sometimes people do this like a little background and center it, and you've got yourself a nice looking picture right there in your project. So it all depends on what you want, how you want to look. Oh, wouldn't do that. Hey, it's not that bad. So there's a lot of things you can do to make your pictures look nicer. Might look good like that right there. Ooh, no, it did a huge background. We don't want that. I usually do this one. Gives a little pop off the page. So there we go right there. We now have a good looking picture of our work. So what does this mean right here? And let's look at the question. We needed a 2-level categorical variable. So identify the level of the variable you will consider a success. So what do you think is a success? Being in the honors program or not being in the honors program? You get to choose it. What do you think is a success? Doesn't matter which way you go. Being in the honors program or not being in the honors program? Success just means the thing you're interested in looking at. So there is... being in the honors program we'll call a success. You could say not. It's fine. Either which way you want to go. So a success is being in the honors program. I would probably say that like I am going to consider a success as someone being in the honors program. That is what I'll be doing. How many successes were there in this data? How many successes were there in this data? So look at this right here. This is also known as X in notation. Yeah, you bet, Evan. How many successes? 93. You got it. What was the total sample size? What was the total sample size? What was the total sample size? Total sample size, hints right there. The size of your sample. What was the size of your sample? So you might say things like this, like there were 93 successes. Like, I don't want to say, I'm too afraid to say too much. I don't want, because like cheating is very serious and I want to kind of be like, I'm kind of telling you, kind of saying what to do right here, kind of talking through this, And then what is P hat right here? Yeah, Rosemary, which one do you want to do? Tell me which one to do in chapter 16. We did chapter 16 homework yesterday, I think. Tell me which one to do in chapter 16 quiz. Evan's got a next one after this. But put the question you want to do, Rosemary, and we'll do it next after this right here. Thank you, Rosemary, so much. What is P hat in this? Because you might say P hat, the sample proportion. And even have a level. Yeah, we could do that at the end of office hours. What is P hat in this? So P hat is X over N, right? What happens if we do that here? What if we go 93 over... Ooh, look at that. 93. These are all good things to write, right? So, I mean, it's right there, right? So that's P hat. That makes that Q hat. And this is technically N minus X. So that's N minus X right there, which I don't think there's a notation for it. It's just the sample size minus the number of successes. So that's what 713 is. If you take 806 minus 93, you get 713. P hat and Q hat add up to 1. So make sure to interpret and fully explain this. I think that's the next part of the question right here. Create a bar chart and frequency table you're choosing. Make sure, oh no, it says you have to have the values over the bars. That's why I got to read the project. You have to put your values over the bars. I don't usually do that. Its values are right there. Please, if you're watching this, please put your values over the bars under histogram options, show counts. Please put your values over the bars. I'm sorry I forgot to do that right there. I'm glad I'm reading the project step by step. I don't usually do. You did that? Yes! I think I did it the first time I did it. But you might have to go back and re-screenshot that. Sorry if you've already closed out your thing. But put your values over the bars. With the second red arrow, you need to click histogram options and then show counts or show percentages.
It doesn't matter.
Either one's fine. Yeah, that's totally fine. You can show percentages. That's fine right there. It's just what it wanted. I don't usually do that just because the count axis is on the right and also it's there. That's what Alyssa did on hers. Yeah, Alyssa's a pro. She knows what's going on. She's not making errors like Brian. Shouts to Alyssa. Thank you so much. Mac users may have a problem with dark mode. Yeah, you have to change your Mac settings to light mode. I've got a video on that too. We found that out like, oh gosh, 2.5 years ago. I don't know if it's still a problem. It's a bummer. Oh, yeah, search stat one video. Include a screenshot of the visualization, provide a short description, writing it up. We did that right there. And now, so many old quotes. Next, create a confidence interval of any percent other than 95. So we actually have to go back to our data. So you wouldn't want to close it out right here. To create a confidence interval, you need to go here to the second red arrow. And under the second red arrow, go to confidence interval. And then you have to select, you can actually select just one of these right here other than 95. So you could just select 90. Moment is gone. So you can select that right there. And as long as you select something other than 95, you get the confidence interval over here. Make sure it's not a 95 as the question says. So now we're going to go and screenshot the following. And there it is. So we're good to go. And there is, let's do a new window. That's how I get so many tabs open. Now, I would once again make sure this is not huge. You want to get it a decent size. Put it in the center of the screen probably. And you can do some backgrounds if you want. So with this, we are going to interpret, I believe, the confidence interval. Let's look at the instructions. Next, create a confidence interval, include a separate screenshot. Interpret to the reader the confidence level, the confidence interval. So the 4 parts to the confidence interval. Who can put in the chat? I know a few people knew. Has anyone had the pre-wrapped chocolate? Ooh, that sounds good right there, Evan. Or that Blake. Yeah, I know it's Evan. I am blank % confident that the true blank is contained in the interval blank to blank. So how would we interpret this? Who knows? And good to see you here, Keith. I am blank. Great job, Julie, right there. So what are we interpreting right here? What are we interpreting? That's where students make mistakes usually. What are we interpreting? What are we trying to figure out? Now be careful. It's not always true mean. It's not always true difference between means. It's not always true proportion. I mean, it's one of those usually. So what are we trying to interpret right here? Remember, we're trying to figure out we said we were interested in this. And this was our estimate of the truth. And here's our interval. So what would be the interpretation? Pretty much, kind of, Julie, you're on the right track. So I think you've got it. So continue on, keep going. I think you got it. I am. And then if it's 88, so on the numbers, yeah, exactly. 90%, and then check your numbers, Blake, right there. Oh, I see what you did. You just added a 0. Great job, Blake. Let's show you some points. So Blake is correct. You just forgot to add the 0 to the 0.09. So great job, Blake, right there. We'll throw you another 10,000. Great work right there. So I am 90% confident that the true proportion of people who are in the honors program is contained in the interval 0.09, 8147 to, and then, yeah, or I would just say to that, between this interval right here. So there we go right there, Blake. Just make sure to carry the decimals, and the values down here are 0.09 and 0.135. So great work right there. Good practice on interpreting the interval. What if somebody told you, they said, I believe that 20% of people are in the honors program. I believe that 20% of people are in the honors program. What if someone told you that? That is their what? That is their what? If someone said, I believe that 20% of people are in the honors program, that is their what? They said, I believe that's true. That is their null hypothesis. So they are literally saying to you, my null hypothesis, when they say, I think it's true that 20% of people are in the honors program, they are saying it this way in statistical notation, that the true proportion of people in the honors program at UT is 20%. Now, you only took a sample of students. You didn't talk to all students, right? So do you know the truth for all students? Yes or no? Do you know the truth for all students right now? Which this is the truth for all students. Do you know this? Do you know about the truth for all students? Do you know the truth for all students? Do you know? You don't. Well, you have a guess of what the truth is, kind of an estimate of what the truth is from the confidence interval, right? So your confidence interval is giving you a confidence that the truth might be contained in your interval. Does that make sense, Blake? Like, you're not saying you know the truth is in this interval. You're 90% confident the truth is in this interval, right? And the interval goes from about 9.8% to 13.5%. So you're 90% confident that the truth is in that interval. So when your friend says to you, I think 20% of students are in the honors program, you offer them to the alternative that it's not true that 20% of students are in the honors program, which is a proportion of 0.20. So the null would be that the true proportion of students in the honors program is 20%. That's what this reads. Let's read it again. My null hypothesis, this is how to read it. My null hypothesis is that the true proportion of students in the honors program is equal to 20%. My alternative hypothesis is that the true proportion of students in the honors program is not equal to 20%. Notice how when I get to that P right there, which is true proportion, I just don't say proportion or I give it full context. I say my null hypothesis is that the true proportion of students in the honors program is equal to 0.20 proportion, right? My alternative hypothesis is that the true proportion of students in the honors program is not equal to 0.20. So, exactly. So what does our interval help us conclude right here? So make sure to include this part too if you've already been doing the project. Make sure to kind of talk about how your interval would help you reject or not reject the null. So what do you notice about the value of 0.20? The value of 0.20 is where to the interval. The value of 0.20 is where to the interval. You're like, I think my 90% confidence interval says that I'm 90% confident that the true proportion of students in the honors program is between about 9.8% to 13.5. The 20% you believe is true is outside my interval. I what that value? The 20% you believe is true, according to your null hypothesis, is what to that, it's outside, so we reject it. Exactly. So we could say, and this is the last little bit to talk about right here, since we are doing a 90% confidence interval, we could also say we reject it at the what alpha level. If we do a 90% confidence interval, and this was last class we talked about this, it's mechanically the same. A 90% confidence interval is mechanically the same as doing a two-tailed test with what alpha level. A 90 close to, so wait, check out right here. So sorry, Julia, right there. So not 5%. Since it's 90%, it's mechanically the same as what? These are meant to be the same as this right over here, 10%. So it's the outside. So it's mechanically the same as a two-tailed test with 0.10 alpha or 10% alpha. So these two values are what's of each other when you do the test versus the confidence interval. If you use the confidence interval to do a test, those two values that the test and the interval are at will be complements of each other. So the outside is the way we can do a two-tailed test on it versus the confidence interval, 90% right there. So they are complements, good check. And you could even say this, that I can reject this on a two-tailed test at the 10% alpha level. So you automatically know that. And had we done the test over here, which can be done by going to test, this is not required, but I do like to do it. And then we put in your friend believes 80% are not in the honors program, 20% are, and we run it, and you can see you definitely reject it. So reject the null hypothesis. Timothy, good to see you here. And I think it's time for Evan's question. So let's head back to the main screen. Let's do this. Okay, Evan's question. Evan says, a new diet is being tested. The inventor claims you'll lose 10. Oh, is it Canvas content? It's Canvas content, right, Evan? So let's do Canvas content, and then there's some chapter 16 people want us to do. Yep. How much free responses on the exam? Interpret intervals, interpret tests. So those are the big things that people are going to make mistakes on: interpreting intervals and interpreting tests. Like that. When I read the responses to the interpret the interval, people are like, this interval is good. And I'm like, no. Or interpret the test, they're like, I accept the null. And I'm like, no. Yeah. We'll probably do one version of the Canvas content right here. We did a lot of Canvas content yesterday. Check it out. We spent like 45 minutes on it. That's why I might go over to chapter 16 quiz after one version of Canvas content. So, okay. Canvas content. The interval is magnificent. Yeah, I about get stuff like that. Mubot says no to accepting the null. Would you really look at my project? Yeah, send it to me as quickly as possible. I've been reviewing like multiple projects. Send it to me as quick as possible. I give a quick skim of the project. So the better it is, the less I have to say. So send it to me as soon as possible. Stat 201, Canvas content number 9. Let's go check it out. Thank you so much. Yeah, Blake can confirm. Send to me as soon as possible. Thank you, Blake, right there. I appreciate that. Okay, a new diet is being tested. The inventor claims that you will lose 10 pounds. Now, some people are going to come in here and be like, you're lying, and we're going to show that you're lying. The easiest way to do this question, I did change it a little bit for my section because I didn't like one of the answers, is to know that the null always has the what. The null always has the what. Thank you, Blake, right there. The null always has the what. This question is a joke right now, but if we know one thing about the null hypothesis, the null always has the what. Anytime you write a null hypothesis, it always has the equal sign. So going off that, you can see you only have one answer. That has to be the answer right there, or answer cannot be determined. Now, good to see you, Lachey. Why are we using mu? Why are we using mu? Let's just do a few extra notes on this. Why does this question use mu? Why does this question use mu? Because it's average. We're talking about the weight people lose, and that's a quantitative value, so that's mu. What is the value of 10 in notation? What is the value of 10 in notation? So what is the value of 10 in notation? Look where it's at in the problem. The value of 10, which will be very important if we were to solve this by hand, the value of 10 is what? Not P naught. Good guess right there, Evan. Not P naught, because P naught is used for proportions. So what is the value? But very close, very close. It's mu naught. So that means it's what? Like, tell me what mu naught means. So no, Evan, good work. We'll throw you some points, Evan. We're throwing some crazy points today. We're throwing some 10,000 points. What does that mean, Evan? What does mu naught mean? So then just say like, oh, it's the this. That is the what mean. Crazy points. Mu naught is the what mean. So it's important to know that this is where mu naught goes. In general format, the null hypothesis is that mu equals mu naught when we're testing quantitative data. So what is mu naught? The kind of the null hypothesis, it's the hypothesized mean. They're saying this is true. They're making this claim. They believe it is true. Does that make sense? It is the hypothesized mean. And that's where mu naught goes, is right here for the hypothesized value when we do a hypothesis test. So always over here is the hypothesized value. This is the true value. So we're saying the truth is equal to this hypothesis value. Mu naught is the hypothesized mean, and then P naught would be the what. So P naught would be what? What does P naught stand for then? Which is not part of this problem because that's categorical. P naught is the what? Think about what the naught means, and then you can figure out what P naught means. It's just good to memorize the notation because it really helps. It's like the backbone of these problems. P naught is the what? It's proportion, but what proportion? Great job, Lachey, right there. Let's throw Lachey 10,000 points for being here and working on this. It's the what proportion, though, which is not part of this problem. There is no P naught in this problem. Not sample. Sample proportion. Good answers, Lachey, right there. Sample proportion would be P hat. Sample proportion is P hat. P naught stands for the what? So remember, mu naught is the hypothesized mean. So P naught would be what? P naught would be odd. Good to see you here, Kayati. Good to see you here. P naught would be what? P naught would be what? P naught would be what? So if mu naught is the hypothesized mean, P naught would be the what? What would P naught be? If mu naught is the hypothesized mean, then P naught would be the hypothesized proportion. Does that make sense? If mu naught is the hypothesized mean, then P naught is like, great job, Evan, right there. Good work. Then P naught is the hypothesized proportion. So that would mean right here, we are talking about the null hypothesis is that the true mean is equal to 10. And then the alternative we're trying to show evidence for is that you won't lose 10 pounds. Now, all of that notation is going to come into very important play right here as we do this one right here. So let's work on the following problem. Here we go. So with this, let's mark the notation. You ready, Kiardi? Good to, let's see right here. Help us out with this. So they claim you'll lose 10 pounds over 25 weeks. And the sample yields an average of this. Oof, that's how much people lost in the sample. And then right here, the standard deviation is 6.9. So, and 25 people are randomly selected. So help me out with the notation for this. And I'll write the equation, which if you have the equation, it's a huge help. So what is the notation for this problem? Like what is each of these numbers equal to? And I'll highlight it down below as you say them. So we're trying to solve for a t with n minus 1 degrees of freedom. So what is the notation? To be like, this is this, this is this, and then I'll tell you what each one of those are. So who can help us out with the notation right here? 10 is mu naught. We were just doing that right there. 10 is mu naught. That is the hypothesize what they're claiming is true. They are claiming you will lose that. The sample size is 25. So we're highlighting up there with the same colors. So we have the sample size is 25, which is n is sample size. The s, which is sample standard deviation. So that is the sample. Oh, wait. Oh, whoops. Look at that. I got it wrong right there. That's the sample mean. So this is the average, the sample average. And then last but not least, the standard deviation is 6.9. Technically, and don't worry, technically it's lowercase s. So technically it's meant to be a lowercase. I'm just very bad at writing. So that is all the notation. Then it becomes a plug and chug problem where we just put in the numbers. So let's go ahead and do this. We get right here 0.6. If a diet says you'll lose 10 pounds and you don't even lose a pound, how do you feel about that diet? If a diet says you will lose 10 pounds over 6 weeks and you don't even lose a pound, how do you feel about that diet? You feel success. It's like weight fluctuation right here. That's like water weight fluctuation is losing 0.6 pounds. So I would not feel success. I'd be like, this diet is one of those fad diets, one of those not true diets. I'd be like, something weird. Diet. Yeah, I think the truth is for medians, what do we find? They could just go off the two sample t for which way to do the sidedness. And then you could mention that. You could say the medians were higher over here, but then the means were higher over here. My guess is also your difference is not statistically significant. Is that true, Taylor, right there? And thank you, Taylor, for swinging by here. Is your difference not statistically significant? Probably there was a small difference between the medians and a small difference between the means, and it just went the other way. And you could say, like, it looks like a lot of these differences are just due to random chance. This high p-value right here indicates, so your p-value is also probably going to be greater than point. It is significant. Send me your project, Taylor. That sounds interesting, that the means have a different direction than the medians. It might, yeah, send me your project as quickly as possible so I can take a look at it and confirm what you're seeing. I might even do it here during office hours just to be like, oh, that's weird, or oh wait, this. So send me out. I am dividing, this is 1.38 on the bottom, and the top of it is 9.4 negative divided by that, and there's the t. Wow. Does anyone know the p-value? Negative 6. Does anyone know the p-value? 10,000 points if you know the p-value to this. You say, how do we got to go to the t-applet to get the p-value? Nah, if you know enough about t statistics by now, then you know the p-value right here. Boom, Evan, right there. You got it instantaneously. Evan, it's 0. Yeah. How do you know? Did you go to the t-applet? And did you go to the t-applet? How do people know that just by seeing like, whoa, that's yeah. Because if you draw the curve, a t with 24 degrees of freedom is going to look kind of, why is it 24 degrees of freedom? Because it's n minus 1. Degrees of freedom equals n minus 1. The degrees of freedom give you the shape of the t. Too many standard errors, technically. This right here is the standard error of y bar. That portion right there is the standard error. So it's many standard errors below the curve. So tomato, tomato. We go right here. 1, 2, 3, 4, 5, 6. We landed right here, somewhere even way over here. And the p-value is that area right there. We're trying to find less than according to the alternative. So that little tiny thing right there is the p-value. If you really want to get the exact p-value, you have to go over here to things like R, and you'd have to go to QT, and I think it's QT. No, it's PT because that's percentage. And then do 1 minus, and the first argument's that, second argument's degrees of freedom. Oh, I don't have to do 1 minus. There it is right there. And then, so options, SciPen, 20. There it is right there. There's the p-value. So it's basically 0. So you're not going to find the exact p-value without software or something to calculate it, but it's so little. Yeah, it could have been a bot. No, don't ban anyone unless they do anything bannable. Unless, as soon as someone does something bannable, they get 1 shot here. You get 1 shot before you get banned. So don't ban anyone unless they do something bannable. We have had people from overseas. There's one guy, I think he was in Russia, who would come here. Good to see you, Dalton. So everyone gets their chance. They can swing by from anywhere overseas during our live office hours. Bans Evan, don't ban Evan. So you can, everyone can be here and partake and learn. And so, yeah. And so if you did it via the applet, you would get the following, which is 0. And if you do it here, you get the following also. Yeah, because we've had a lot of people from multiple places come by and learn. So it's really cool. But as soon as if you say something you shouldn't, or you treat people poorly, then you get banned. And you get 1 shot. Because we're here to have a productive, fun learning environment, and people are always welcome to join in from many different schools. I've actually gotten emails from people from other schools saying, hey, I used your videos. I'm like, yay! Thank you so much if you're watching this from another university. So, ban Evan. If we construct a 95% confidence interval that does not contain the hypothesized value, which of the following statements is true? So let's construct a 95% confidence interval, and it does not contain the value, kind of like this one over here. So if you construct a 95% confidence interval, 95% confidence intervals are the same as doing a 2-tailed test with what alpha level? So a 95% confidence interval is the same as doing a 2-tailed test. Look at the confidence interval right here with the middle shaded in. And then, well, not 2.5, 5%, right? So the confidence interval is the inside and the 2-tailed test is the outside. It'll come to the same conclusion as a 2-tailed test with 0.05 alpha. So what do you notice, which we said earlier, about these two values? These two values right here are what of each other? The confidence interval is the same as a 2-tailed test and will come to the same conclusion, and they are what's of each other? So to see the analogous result, they are complements with an E. Blake will never forget that. Great job, Blake, right there. So now let's hit we don't hit the points button too often. There's too little of points. So if the value is outside the interval, which you see right here, if this hypothesized value is outside the interval goes from 9.8 to 13.5, what would you do to a value that is outside the interval? And we can draw it a little bit better over here. That if you have an interval and anything inside the interval, we would what? Versus anything outside the interval, we would what? So outside the interval, we would reject. And inside, we fail to reject. And I want us to think about this. Your friend tells you that the average selling price of a PlayStation 5 in a store right now is between about, they say about $450 to $650. They're like, well, you know, depending with accessories and stuff, you go to the store and sometimes they got a little bit of a sale going on. But I noticed that the average selling price of a PlayStation 5 is somewhere between $450 to $650 in a store. So then your friend walks up to you to say, and they say, dude, I was just at GameStop and they were selling PlayStation 5s for $100. What would you say to that friend? Like Brian, the business analytics person, has told you that we are 95% confident the average selling price between stores. Ban him. Well, you take a look at the value right here that your friend is telling you, and you're like, your value is outside my interval. I'm gonna reject that. That's the average selling price at the GameStop right now, because that value, I'd get 100 of them. Yeah, I mean, you could at that point, right? You'd like, just give me all of them. Oh no, Timothy's about to go on eBay or something. Why does everyone hate Xbox? You know, when I go back to Knoxville, I might get a Xbox. What is it called? Oh my God, Series X. That's what they're called. I'll probably, I don't know. Do I need one? I was Xbox. Really quick story. My first modern gaming system was a GameCube. Best system ever, probably. And then I went PlayStation 2, played that for a good bit. So that's same generation of systems. Then I went Xbox One. No, Xbox 360, Xbox One. So I stayed Xbox 3 generations. Like I switched over to Xbox, then Xbox 360, then Xbox One. I hate the name of Xboxes. That's why right there. Xbox making it impossible to remember what's what. And then PlayStation 5, just wanted to switch back, especially to play like the God of War games. So new God of War, haven't played it yet, but man, it looks insane. I'm trying to avoid all spoilers on that. But check out Kratos' latest journey with his son in God of War Ragnarok. Sponsoring Statua 1. The Xbox 360 One, and then they came out with the One S. Then the Series X came out, because those are just like mid-generations, right, Blake? Almost. Yeah, then they had like the Xbox One X and those were like mid-generations, like the One, and then the Series X is the new generation, like that you can't play the games from the previous gen on. If we're going to start a 95% confidence interval that does not contain the hypothesized value, we would reject that value with the 0.05 alpha. These are complements, and anything outside the interval we can reject. Now, here is the easy things to remember. Thank you, Taylor. We'll check that out here next. Here's the easy thing to remember. Let's review this right here. You ready? In a type 1 error, the null is what? Practice this with me right now. Memorize it. In a type 1 error, the null is what? In a type 1 error, great job, Timothy, right there. The null is true. Now, if the null is true, be very careful. I'm about to try to trick you here. What should you do to the null? If the null is true, like if I tell you, oh, Xboxes cost $600 down at GameStop, and that's true, what should you do to that? Be careful. I'm trying to trick you by asking what should you do to that if the null is true? If the null is true, what should you do to the null? I'm not asking about the error yet. If the null is true, what should you do to the null? If I tell you something true, you should what the truth? You should reject the truth? You should reject it? I'm trying to trick you right here by asking it in a more complex way to help review it. And you should not so don't worry, Evan, I was trying to trick you right there. You should fail to reject it, right? So in a type 1 error, so that's why we're reviewing it a little more in depth. We always try to go get that strong knowledge of it, right? In a type 1 error, the null is true and we what it. So now I'm asking about the error here. In a type 1 error, the null is true and we make an error by whatting it. Exactly right there. We reject it because we should have what? So finish the thing. And this is just the more in-depth knowledge of it. Because we should have what? In a type 1 error, the null is true and we reject it, but we really should have done this because we made an error. We should have what? Because we made an error. Someone tells you, oh, Xboxes are $600. And you're like, I don't believe that. I reject that. You should have not rejected it. So that's what a type 1 error is. Now, the easiest way to remember it again, to review, if you're going for the intro knowledge to this topic, is you could try to fix it, especially if you know it's an error. But unfortunately, the only way you find out these things are errors is by finding out you were wrong and you made the wrong call. And then it's like, whoops, made the wrong call, made an error. And so that's what happens with statistical testing sometimes is we make errors. So in a type 1 error, the null is true and we reject it when we shouldn't. So the null is true and we reject it. In a type 2 error, the null is what? In a type 2 error, the null is what? What letter am I making right there? That I'm trying to charades a letter for you. The null is false, and we what? The null is false, and we fail to reject it. Great job, Blake, putting these notes in the chat. I'm going to pin what Blake said right there. Blake's putting those notes, ways to remember it. Type 2 error, the null is false, and we fail to reject it. Exactly, Blake. And so if the null was false, we should have done what? Like, make sure to say that. If the null is false, we should have done what? If the null is false, we should have done what? If the null is false, we should do what? Pinning this one right here. If the null is false, we should do what? This is the advanced knowledge and the advanced reviewing of it. If the null is false, we should do what? We should reject it, right? Does that make sense why a type 2 error is when the null is false and we make an error because we failed to reject it? So if the null is false, you should reject it. But we're going to make an error and fail to reject it. We don't purposely make these. It's just that you're doing testing and sometimes you make mistakes on rejecting or not rejecting, and it happens. We'll go into more detail on that on this during class today. But good stuff right there. And we only have a little more time. So let's try to do that chapter 16. Someone asked. A type 2 error is when the null is false and we fail to reject it. Got it. Low p-values are evidence of a cause and effect relationship. What do you think? What do you think when you see cause and effect? What's your first instinct here in Stats 101? You see cause and effect and you're just like, yeah, false. Some quiz. And do check out yesterday's versions. We're going to speed run this real quick right here. We'll see how quickly we can do it. So please check out yesterday's office hours where we went more in depth. Great job, Blake, right there, getting the 10 out of 10. So check out yesterday's office hours, way more in depth on this. More versions, you can check it out. But if you get this down right here, there's that. Did I get the same numbers? They look to be the same numbers. Hopefully I didn't mistype a number. Null has the equal sign. Type 2 errors when the null is false and we fail to reject it. Low p-values are evidence of cause and effect relationship. No. A small p-value provides stronger evidence that is true. Lower the p-value, the more evidence against the null. Because lower p-value just means less likely that the null is true. Or less, oh my gosh. Our observed results were less likely given the null is true. It's a contingent probability. But there we go. Good practice. Less than 1 minute. But you don't want to just memorize the questions. You want to understand the theory behind the question. So it's not about memorizing answers. It's knowing the theory behind them. So make sure to do that right there. I think we have time. Everyone says evidence, I swear. So great work right there. Because cause is an invalid word in statistics. Kind of, you can do, there are ways. Evidence, evidence. Evan Evans. Evan. What is the band's name? Band name from the early 2000s? Evanescence. It's a good band. I had a song like Bring Me to Life. Good stuff right there. Chapter 16 quiz was asked about, but I don't know which question on it. Always feel free to drop questions from the... Got an R help question. Or maybe, Spanbauer is posting about it. Spanbauer is such a pro. who's showing how to host stuff. Let me look at Taylor's thing right here. All right, I'm looking at Taylor's email. Thank you, Taylor. Personal email here. Yeah. And so, Taylor, if you're still listening, really great work. Let me know if they... But, hey, Justin, right here. Oh, Rosemary's got the one. The Clean Air Standard one. The Clean Air Standard one. So, really good job right there, Taylor. Really good example. Taylor was 100% right. Taylor has a really interesting problem, and that's what we do in statistics. We deal with interesting stuff. So, I'm going to listen to my most chill song. Everyone knows my most chill song. This song right here is just absolutely mellows me out. Is the most mellow. So the first one I see from Rosemary right here is the Clean Air Standard one. We love this song right here. Putting you to sleep, Justin. The Clean Air Standard. Welcome to the Clean Air Standard. We're gonna work this problem. Chapter 16 got a lot of problems. Clean Air. We did the whole homework yesterday. Yeah, grab some coffee. Clean Air Standard. I wish you could do a search through these. Find it. I gotta send the email about class today. Someone was like, do we have class? And I was like, yeah. And they're like, oh, no email. And I was like, oops. Nice job. Great job, Justin. How does the Clean Air Standard one start? Oh, here it is. Clean Air Standard. Found it. It's literally question 24 of 25. I was getting worried. Literally at the last moment right here. Slight flex. Hey, let's throw some points for that. I'll take that slight flex. I know you're emailing me about a few of them, and really think that's great right there. I'll take that slight flex. 943, Statue 1, Chapter 16, Quills. Okay, big flex right there. Love it. 10,000 points. I think we did that one yesterday, or maybe we'll try to do it right here, Taylor. Yep, we have one more question before this, and we have class in 19 minutes. So let's do this question. Here we go. A Clean Air Standard requires the vehicle exhaust emissions not exceed specific limits for various pollutants. Many states require that cars be tested annually to make sure that they meet the standards. Suppose state regulators double-check a random sample of cars that a suspect repair shop has certified as okay. They will revoke the shop's license if they find evidence. Okay, wait a minute. So what would be the null hypothesis here for this repair shop? What would be a good null hypothesis for them with their license? Let's write a null hypothesis for this repair shop. So what would be a good null hypothesis for this repair shop about them and their license? What would be a null hypothesis for this repair shop with them and their license? Let's write it out in words right here. What would be a good null hypothesis? So if they find evidence they do not meet standards, they will revoke their license. So what is their null hypothesis? Pretty much, Justin, exactly. So should it be that they keep license null or revoke license null? So should it be keep license null or revoke license null? Because this is the evidence. You got it. Keep license. Great job, Justin. You can't just revoke someone's license. You need what to revoke someone's license? To revoke someone's license, you would need what? Which is why it's the alternative claim. To revoke someone's license, you should bring what? Just keyword evidence. Justin, you got this down. You need evidence to revoke someone's license. So we're going to assume they're meeting the standards till we have evidence they don't. And then if we have evidence they don't meet the standards, we're going to revoke their license. Now, before looking at their questions, let's just review type 1, type 2 error. In a type 1 error, the null is what? You only have to type one letter in the chat. In a type 1 error, the null is what? We're going to make this a quote right here. In a type 1 error, the null is true. And then what do we do to the null if we have, what do we do to the null in a type 1 error? In a type 1 error, the null is true, but we're going to what it? Like right there, Evan. In a type 1 error, the null is true, but we reject it. So in a type 1 error, think about this. That means they are whatting the standards. In a type 1 error, it's right up there, right? They are whatting the standards in a type 1 error. The null is true, right? So in a type 1 standard, tell me about the shop. Remember, the null is true. In a type 1 error, the null is true, so they are whatting the standard currently. The null is true, right? They are meeting the standards. But we're going to reject the null and be like, nah, you're not meeting the standards. They're like, oh, we're doing everything right. We do it. But it was revoked. So we mistakenly, for some reason, the sample of cars we got was a sample that just was weird. And we're going to say we have evidence that you're not meeting the standards, and we're going to take away their license when we shouldn't. So the type 2 error is kind of the reverse of that. In a type 2 error, the null is false, and we fail to reject it. So if the null is false, tell me about the shop right here. In a type 2 error, the null is false, and we fail to reject it. So if the null is false, what about the shop right here in the type 2 error? In a type 2 error, the null is false, and we fail to reject it. So tell me about the shop. Just tell me about what's going on right here. You have to be like, that is false right there. It's false that they are meeting the standards, because the null is that they're going to keep their license because they're meeting the standard, but that's false. But we're going to be like, hey, we didn't find anything out. And they're like, yeah, haha. They are not meeting the limits, but they keep their license. The cars are not meeting the standards, but they get to keep their license. The null is false. They should not keep their license. But we're going to fail to reject the null. So we're going to make an error and let this criminal shop go and keep doing what they're doing. So that's a really good review, and I think that's all they're asking right here. Let's take a look at the questions. They might get into power at the end of this, and I'll speak about that. What is a type 1 error? In a type 1 error, the null is true, and we reject it. So we revoke the shop's license when it is certifying vehicles that meet the standards. Remember, the null is true, so they are doing what they should be doing, and we reject it and revoke their license. Check out where we're just doing that. Type 2 error is the reverse. We do not revoke it when they are certifying cars that do not meet the standards. What type of errors would the shop owners be most concerned about? Ooh, this is cool. The shop owners would be more concerned about a type 1 or type 2 error. Which one do you think? Type 1 or 2 in the chat? And we've got the context here of a type 1 and 2. Type 2 is when the regulators do not revoke the shop's license. And type 1 is when they revoke the shop license when they're meeting the standards. So it'd definitely be a type 1 error. They're more concerned about that. The shop owners would be more concerned about type 1 error because the owners do not want to see it revoked, right? So what's the other one say? Because the owner would not want to know if the shop's, which would be more about the environmentalists. This is a really great question right here because the context of why we care about it, like who cares, is all context. So it'd be type 2 right here. The environmentalists would care about a type 2 error. It's more serious because they do not want faulty cars on the road polluting the environment. It's way more serious because they want cars on the road. The wording of this way right here, because the type 2 error is we do not revoke when it is certifying cars. So it's about certifying cars, okay, that do not meet standards, okay. Because they do No, it's not faulty cars. Not faulty cars. That's where I almost got tricked. They do not, because they want correctly certified cars on the road. That should be right there. What? Are you serious? This is ridiculous. Because they want... Why in the... Wait, let me read this. What in the world? More serious because they do not want faulty cars on the road polluting the environment. Yeah, that'd be they want correctly certified cars. It's virtually the same thing. No, just tell me if you got this last thing wrong, because that's ridiculous. It's clear that we're just saying that the way I would explain this, if I had to write it out, the environmentalists would be more concerned about a type 2 error because the shop is putting cars on the road that are not properly certified. So that's why when I saw the correctly certified, which is part of the error up here when it talks about the type 2 error, it says when it's certifying cars that do not meet standards, so correctly certifying. Yeah, that's a bit weird. Just the last part was that. Just tell me if you missed that. Be like, hey, Brian, you missed this during office hours. I missed it. So you get the little extra right there. Just the way they word it sometimes, a little... It's quite clear that they're worried about a type 2, though, which is the whole point of the question. Let me email about class, and let's do one more question right here. So let me email the class about the class, because I forgot to last class. And then a few people were like, what, did we have class? And I was like, yes, we did. We always have class. We'll never not have... Well, I mean, I can't promise. I don't know. You never know. It's rare to never that we don't have class. Okay, 10 minutes till class. Okay. Announcements. Announcement. Class in 10 minutes. Click here. Okay. There we go. Make sure link works. Make sure you send out, because I've definitely not sent that out before. I think we have time for one more. That's such a weird one at the end. I'm going to miss that every semester now. Like, this is a new one this semester. The other one, and thank you, Rosemary, for asking about these. The clean air or company survey. Company survey is the other one. Okay. Company survey. Let's see if we can find out one real quick right here. I like the bank one. So many questions. Company survey. Okay. So, woof. Want some confidence rolls. Okay, we're going to have to speed run this one. Who's ready for a little Stat 201 speed run right here on these wacky Wednesdays? Was the last day of school a week from today? What? I totally forgot about that. Is that quote 282D? Oh, no, I think it's doing a random quote for you, Blake. When you do the D at the end of that, it doesn't find the quote. I don't even remember when that quote is from. So it's... it just does random quotes. If you do exclamation mark quote, it does random quotes. So here we go. We're going to do one last question right here. Speed run. So this is a speed run. We're going to have to do it quickly right here. We'll see how quickly Brian can go. Speed run of this, because we only have a little bit of time for class. Okay. Okay, so to start this question off, a company surveyed 2,300 men. So that's the sample size right there, where 1,127 of them, that's the X, which is the number of successes, identified as the primary grocery shopper in their household. I'm kind of that. Chelsea does grocery shopping too, but I'm all about, let's go to that HEB and get some groceries. Love some HEB. Sorry, we'll come back to Knoxville. Love some HEB. Estimate the percentage of all males who identify themselves as primary grocery shoppers using a 98% confidence roll. So we're going to find the Z-score for that. It's 2.3263. We'll show that here in a second. The David M. Lane applet can get you the Z-scores. So make sure to go over to the David M. Lane applet. So HEB is the best. You know some HEB right there. So Texas grocery store right there. So the Z-score would be found using an applet, typing in 98% on the second tab and going between 2.3263. Z-scores never change, so you can get the same Z-score every time. That'll be the Z-score for the 98% confidence roll. If it asks for a different one, you have to look up the other Z-scores like 1.96, 1.645, but they stay consistent for the percent interval. Check the conditions right here. We're not going to be using the nearly normal. I really hope it's not going that way, because we are doing things like the 10% condition. This is a ridiculous amount of conditions. We know what our conditions are. Our conditions are condition 1. Random right here. A survey completed. It's not because the samples were drawn from a convenience sample. I don't see anything about a convenience sample. I am worried about this, the way it's phrasing it. There's nothing to indicate the samples were not drawn randomly. Good. 10%. Here we go. I think I clicked the wrong one. Is that less than 10%? No, we want less than. So less than 10% is 10% condition. This is good. This is good. And then they're trying to trick you here with the nearly normal. Nearly normal is for quantitative data, so nearly normal is not going to apply. All necessary conditions, see they're very, very specific right here. You're not going to check nearly normal. The success failure condition, since remain a constant interval, means there must be at least 10 successes and at least 10 failures right here. So the fewer than is wrong. We want at least 10 successes. If these are the right answers, they've done a perfect question right here and a great way to review it by random, 10%, and success failure. Absolutely love it. To make the confidence interval right here, we need to find p hat, which is going to be x over n. There's x over n. And now we need to do, oh my gosh, p hat. I'm actually going to cheat and show this in R right here. There's p hat, because we only have a little bit of time. P hat, q hat is 1 minus p hat, which is 0.51. And then the standard error of p hat. Standard error of p hat is p hat times q hat over n. N is equal to 2300. P hat times q hat over n square root. SQR2, we are speedrunning this because we have 5 minutes of class. There's the standard error. And now the confidence interval is p hat plus or minus. So we do the z-score of 2.3263 times the standard error. Got to put the star in. And there's the upper. And there's the lower. And so there is p hat plus or minus the z-score. And then the standard error of p hat times q hat over n square root. And that should be right. Software makes it a lot easier to calculate these things. So there's the upper and there's the lower. Make sure to round. It looks like we've rounded properly. We are speedrunning this. And there's that. Okay. What does the confidential say about the grocery store owner hypothesis? What did they believe? 44%? Well, we don't believe that. Because 44% is not in the interval, we do have evidence. We have strong evidence that more than 44% of men identify as the grocery store buyer. So, yeah. Determine the level of significance that this test was done at. So now it's asking about what we talked about earlier. Yeah, the level of significance for the alpha. Since you're going to two tests. So, oh, is this one-tailed versus two-tailed? Oh, no. This is going to be interesting. A grocery store owner believes that only 40% of he wishes to conduct a hypothesis to see if the fraction is in fact higher than. Oh my gosh. I'll have to tell Terry this question is not one we cover, and so I don't like it. So he is doing a one-tailed test. And they are saying what to do right here. They're saying we have the area. So it should be an alpha of 0.01. There we go. So if you do a one-tailed test, you would have the area. So if you were to do, does everyone hear this? And they are kind of alluding to it. It's a little bit tougher. I might mention it today in class. If you were doing a one-tailed test, what would be the respective alpha level of this? So we got to end this here. If we were doing a one-tailed test, what would be the respective alpha level? So if we were doing a one-tailed test, 2.5, and they allude to that right here, and you know he's doing a one-tailed test because he's testing higher than. So he's saying higher than, which I noticed right here, the more than. So that indicates a one-tailed test, which is the greater than. So you have to cut it in half, and they do indicate how to do it. And since it's a 98% confidence interval, you would cut it in half. This was a pretty tough question. Like this question right here is one of the ones, if you understand it, you really know this chapter. So good work right there. It also has review from other chapters in it. We're going to head off and start class here in a few minutes. Bye!